Algebra 1, number 5.10a, multiply binomials, special products. Multiplying a sum and a difference is what we're going to do in this video. Sometimes when we need to multiply two binomials, they look almost the same, just their signs are different. Look at these two. X plus 3 times x minus 3. They're exactly the same, aren't they? Except for the signs. The first terms are the same, and the only difference between the last terms are their sign. One's a positive and one's a negative. Well, when this happens, it suggests the rule of multiplying the sum and difference of the same terms. So check this out. The product of a plus b and a minus b, it's the product of the sum and the difference of two terms. It's the square of the first term minus the square of the second term. So when we see two binomials and the only thing that's different about them is one's a positive and one's a negative at the end here, see that? All we have to do is quickly write a squared minus b squared. See? We save a lot of time doing that, don't we? Instead of having to do the FOIL method. So this is how the rule works. If we solved it using the FOIL method, remember, first, outside, inside, last, we would multiply the first terms inside the parentheses. So this is the first term and that's the first term. So we would get x squared. Then we would do the outside ones. This x is outside and that negative 3 is outside. So we get a negative 3x. Now we do the inside ones, the 3 and the x. So we get positive 3x. And now we do the last terms. This 3 is the last term in that parentheses, and this negative 3 is the last in that parentheses. So we get minus 3 squared. See? We're just using the distributive property twice, aren't we? We're using it once for this x and again for that 3. See? We combine the like terms. This minus 3x and this plus 3x, they make a zero pair, don't they? They make an additive inverse of each other. So this ends up becoming x squared minus 3 squared. See? This would be minus 9, because 3 times 3 is 9, right? It's the same thing as x squared minus 3 squared. Well, we could have saved time and effort by using the rule for the product of the sum and difference of two terms. The only thing different between them is the plus and the minus sign, see? So all we had to do is say x squared minus 3 squared, see? We could have saved ourselves a lot of FOIL work, couldn't we have? Isn't that great how we can do that? Well, this works for terms with coefficients and negatives also. But remember, it's only for the binomials that only differ by their signs, okay? So we have 2a plus 5 and 2a minus 5. So we know it's going to work with these because these are the same except for just the signs, right? So what we're going to do is we're going to square the 2a. So we have 2a squared. And then we're going to put a minus sign and the 5 squared. See? So remember, the parentheses with the exponent on the outside means the 2a is the base. So that means the 2 is squared and the a is squared. Okay? So make sure that you put it on the outside. When we simplify this, we distribute this 2 to each one. So we get 2 of these. That's 2 times 2 is 4. So we get a 4. And we don't know what a is, so it's just a squared. So we get 4a squared. And 5 times 5, well, that's 25, right? Remember, the exponent says how many times to multiply the base to itself. So we square the first expression and subtract the square of the second expression. Take a look at this one with negatives in it. We've got a negative 4c minus 10d. See, now we've got the minus in the front. Before we had the plus in the front. And now we're going to multiply it to negative 4c plus 10d. The only thing that's different about these two binomials are their operation signs right here. One's a minus, one's a plus. So we're going to square the negative 4c. We're going to put it inside a parentheses, so its entire negative 4c is the base and the 2 exponent on the outside. And we're going to do the same thing with the 10d. We're going to put the 2 exponent on the outside, see? And we're going to subtract them. So now we've got negative 4c squared minus 10d squared. See? We can simplify this. If we do negative 4 times negative 4, we get a positive 16. We don't know what c is, so it's just c squared. We're going to subtract 10 times 10. And that's going to be 100d squared. See? It's a lot easier than doing FOIL. So remember, it's only when they differ by their sign, okay? They look almost identical. It's just their signs are different, okay? Their operation signs. So we end up with only two terms because the O and the I parts of doing the FOIL method create a zero pair. See? This is the O and that's the I. This is the x minus negative 3. That's the outer. And the inner, the 3 times x. Between those two, the O and the I part of FOIL create a zero pair, the additive inverses of each other, okay? So if you can remember this or write this down, the square of the first minus the square of the second, okay? That's what you need to remember, the square of the first minus the square of the second when they're the same except for operation signs, okay? So for binomials, multiplying a sum and a difference is the square of the first minus the square of the second, all right? And if you're confused or want to review the FOIL method, which was a couple videos ago, or multiplying binomials, or exponents in parentheses to understand why the exponent is on the outside, there'll be a link into this description so that you can just click on it, okay? Our next video is going to be number 5.10b. We're going to talk about squaring binomials, okay? I hope I'll see you there. I hope this was helpful, and I hope you're doing all right, all right? I'll see you. Bye.